Right, in this video, we are going to look at factoring the difference of squares, and we're going to look at factoring the sum and difference of cubes. Difference of squares we did in Algebra 2. Sum and difference of cubes, because of the way the year ended, we didn't have time to get to that, so that part is going to be new for this video. Normally, you would do that in Algebra 2. Okay, so here is a difference of squares formula, or difference of squares problem. And there are two different ways to do this. I know in my class we did both ways. Other teachers may have only done one or the other, but I just want to show them both to you so that you have options. So if we look at this and think about standard form of a quadratic, ax squared plus bx plus c, I see that right here I have the ax squared term, and right here I have the c term. It just so happens in this case we have an extra variable. You know how sometimes we would have an extra variable in there? So that's what it would look like. But that's still the a term and the c term. What's missing is that b term there in the middle. So in order to do factoring by grouping, like we did in the last video, we have to add in a zero term in the middle. So I'm going to do that, h squared plus 0, right? Because if I add 0, I don't change the value. And it's going to be 0hw. Remember, the variables have to match. I've got an h and a w. Minus 64w squared. Okay, well now we're going to be able to identify a and c. So a in this case is 1. It's that understood 1 in front of the h squared. And c in this case is negative 64. So when I multiply those together, a times c, 1 times negative 64 is negative 64. So what I'm looking for is two numbers that multiply together to be negative 64, and they add together to be 0. Well, in order for them to add together to be 0, the numbers have to cancel out. They have to be opposites of one another. So two numbers that multiply to be negative 64 and are opposites of one another, negative 8 and positive 8. Okay, let's go put those in the formula. So you remember the a part doesn't change. The b in the middle goes away, and it becomes the two new numbers that we just figured out. And then the c term on the end, it doesn't change either. All right, I'm going to cut that in half, just like we did when we were factoring by grouping before. All right, and let's do the GCF. The GCF of these two, I can see it's going to have an h. And remember, I always pick the smallest exponent. Smallest between that understood 1 and 2 is 1. So that's going to be the exponent there. And now I subtract. 2 minus 1 is 1. And here the 1 minus 1 is 0, so there is no h, and it's just going to be 8w. All right, so now I look here. I've got 8hw and 64w squared. I need to get the GCF of those. The GCF between 8 and 64 is 8, and that's going to be a positive because I need my signs to stay the same. There's not an h in the GCF because they don't both have h, but they do both have w, and the smallest exponent is 1. And now let's divide. 8 divided by 8 is 1, and I still have the h there. Negative 64 divided by positive 8 is negative 8. And subtract my exponents. 2 minus 1 is 1. All right, now remember we said last time it's really important that what's in the parentheses is exactly the same, and in this case it is. So we'll factor that out in front, h minus 8w, and what we have left over goes in the second parentheses, h plus 8w. All right, and that's going to work out to be the answer. Let me scoot that back over, sorry. Okay, so notice that in this case, what's inside the parentheses is the same, except that this one is a minus and this one is a plus. Everything else about it is the same. So if you want to, if you can remember that pattern, when you see something where this one is a perfect square number and this one is a perfect square number, it's okay to go ahead and say, okay, I know what's going to be in the parentheses is exactly the same, except that one of them has a minus and one of them has a plus. And it doesn't matter which order you put them in as long as you get them both. So if you can remember that, if you can use the pattern, that's okay to do also. All right, the new thing we want to focus on is factoring the sum and difference of cubes. Okay, so look, this one has two terms, just like the one we looked at right here has two terms. So how are you going to tell the difference? Well, if it's a difference of squares, my exponents are going to be 2's. But if it's a difference of cubes, my exponents are going to be 3's. So as soon as you see a 3 right here, you're going to know this is the formula you need to use. The sum of squares we talked about last year, the sum of squares does not factor in the real numbers, but the sum of cubes does. So in this case, we have a formula for the difference of cubes, and we have a formula for the sum of cubes. Now, at this point in the semester, I'm not going to make you memorize the formula, but later on, after we've used it for a while, later on, you're going to need to have this memorized. Most of your college professors are going to expect that you have this memorized. All right, in my formula, just so you know what you're looking at, F stands for first, and S stands for second. So whatever that first term is, the thing that is cubed is going to be F. Whatever that second term is, the thing that is cubed is going to be S. All right, and to help you when we get ready to memorize it, notice that what's in the first parentheses is the same on both of them. What's in the second parentheses is the opposite. And then this last one is always a plus. So same, opposite, plus. Same, opposite, plus to help you remember when we get ready to memorize that formula. Okay, let's see if we can put that formula to use. Here's our first one, x cubed minus 27. Well, I know I'm going to use this formula because I see the minus right there. So that tells me it's a difference of cubes. I know it's not difference of squares because I see that 3 right there. And one thing I want to point out real quick before we get started, it's not like this is the question and like you've solved something over here. All you've done is rewritten this into a different form. And I'll show you in just a second what I mean by that. So this is simplified form. This is factored form. Sometimes simplified form is helpful. Sometimes factored form is helpful. But it's just two different ways of writing the same thing. All right, so let's see if we can do some factoring. So I want to figure out what F is. F is the thing that is cubed to give us this first one. Well, this one's a little bit easier. What is cubed to give me x cubed? Well, that would be x. So F is x, which means that in this part of the formula, in this part of the factored form, everywhere I see an F, I'm going to put an x. So I'm going to put x here, I'm going to put x here, and I'm going to put x here because that's where I see all the f's in the formula. All right, now I need to figure out what is cubed for this one. Well, this one's a little bit more complicated because you don't see a cube. So some of you may be able to figure this out in your head. Some of you may need to use your calculator. Some of you know where that cube root button is on the math screen. You can use that, or you can just type things in and multiply them together 3 times. However you do it, you have to somehow figure out that the thing that is cubed to give us 27 is 3. 3 times 3 times 3 is 27. So everywhere in the formula that I have an S, I'm going to replace it with 3. Well, there's an S here, there's an S here, and there's an S here. And the only thing I need to do to get the final factored form is just to simplify. Well, in this first parentheses, there's nothing to simplify. Got x minus 3. And in the second parentheses, x squared, nothing to simplify there. X times 3, we just don't usually write it that way. Usually we write 3x. And then 3 squared is 9. So that is the final factored form. Okay, so I told you that I would show you how this works out to be the same. This is how you're going to check your work. What you would do, and we did a little bit of this last year, hopefully you remember, we're going to distribute these over here. So I'm going to take this x and I'm going to distribute to all 3 of those. X times x squared is x to the 3rd. X times 3x is 3x squared. And x times 9 is 9x. Okay, now I'm going to do the same thing. I'm going to change colors. I'm going to do the same thing with that -3. I'm going to distribute -3 here, here, and here. So negative 3 times x is negative 3x squared, and I'm going to line it up with this x squared term, so I already have my like terms together. Negative 3 times positive 3x is negative 9x, and negative 3 times positive 9 is negative 27. Now, if I take all of those terms and I add them back together, I get x to the third. Negative 3x and positive 3x cancel out. Positive 9x and negative 9x cancel out. Minus 27, which is what I started with at the beginning. So this is the factored form of this, but they're still the same thing. If I graphed it, I got the same thing. If I tried to solve it, I would get the same thing. No matter what you do, those two things are the same. Okay, so there's an example of difference of cubes. Let's do a sum of cubes. All right, here's a sum of cubes. Just like before, I have to figure out what f is going to be and what s is going to be. Okay, so I'm going to look at this one, and I have to ask myself what cubes to be 8y to the third. What can I multiply by itself 3 times so that I get this? Well, the y to the third part is not hard. What cubes to be y to the third? Well, that's y. Now I have to look at the number. What cubes to be 8? What do I multiply by itself 3 times to get 8? And again, you can use the cube root button on the math screen of your calculator. You can just type things in until you guess it. Somehow or the other, you're going to come to the reason that it's going to be 2y. So 2y cubed is 8y to the third. Okay, so that means everywhere in the formula that there was an f, I'm going to want to put a 2y. So I'm going to put 2y here. I'm going to put 2y here. I'm going to have to use parentheses because of that exponent of 2. And I'm going to put a 2y here because I can see I'm going to have to multiply some things together. So I'm going to go ahead and use parentheses to mean multiply. All right, same thing. Let's find s. What is it that cubes to give me 125 q to the third? Okay, well, the q part's not hard. Q to the third is q to the third. So how about the 125? What multiplies by itself 3 times something times something times something is 125, and that something is 5. So my S is 5Q. So everywhere I see an S, which is here and here, and I'm going to use those parentheses, and here, I'm going to have 5Q. All right, and then you remember our last step is to simplify. So in that first parentheses, 2y and 5q, there's nothing to add or subtract there, nothing to simplify. They're already not like terms, so I can't do anything else. So in the second parentheses, notice that this squared goes with both of those. That's why I had to put the parentheses there. I need to square the whole f term, which means I have to square the 2 and the y. So if I square 2, I get 4. I square y, I get y squared minus, okay, now I'm going to multiply these in the middle, 2y times 5q, 10, and I'm going to write qy. It really doesn't matter. We just usually put things in alphabetical order. If you put 10yq, it's the same. It doesn't matter. And then the last one, all right, just like before, those parentheses tell me I have to square the 5 and I have to square the q. I have to square everything in there. So 5 squared is 25, and then q squared is q squared. And so that is the answer, 2y plus 5q in the first parentheses. 4y squared minus 10qy plus 25q squared is the second parentheses. And you need both of those parentheses to be the final factored form. You're going to have both of those things in your final answer.